protein rate, which in turn may depend on the fat content of the meal. Second, we found a marked increase in the beta cell function, here represented as the slope of the dose-response function relating plasma glucose and insulin secretion rate, and this was also combined with an increase in GLP-1 levels, suggesting an incretin effect. And final mechanism, we also observed a small but still significant decrease in insulin clearance. Now, this morning we have heard about the striking importance of beta cell function in the natural history of type 2 diabetes. And I can guarantee you there are not so many interventions able to acutely improve, or I should say restore, beta cell function so much in type 2 diabetes as we can observe in this study. And so we were really interested in deepening our knowledge on the biological signals by which the beta cells could be so much activated. So our first hypothesis was that it could relate to the plasma metabolites of the digested nutrients, and therefore we measured plasma levels of non-esterified fatty acids and of plasma amino acids, and indeed we show a marked increase in plasma amino acids levels. But more importantly, this gradient in plasma amino acids correlated strongly with both the enhancement in glucose sensitivity, parameters of beta cell function, and also with GLP-1 levels, thereby supporting the hypothesis of a direct and GLP-1 mediated enhancement of the glucose-stimulated insulin secretion by plasma amino acids following nutrient consumption. So until now I've been talking about the glucose lowering effect of nutrient preloads, and this may apply to this first real world scenario, perhaps most frequent, when you have only one dish in your meal with all the macronutrients mixed together. So the only way to reduce your postprandial glycemia using nutrient sequencing would be to add a small glucose-free nutrient preload. But what if your food looks like this one on the right, or whether your meal consists in more than one dish with different macronutrient composition? Well, in this case, it seems that you can actually try to follow the right nutrient sequence of consumption without adding further food to our meal. And this has been elegantly demonstrated by several studies by different groups. Here I'm showing data from a group from the United States and from Japan, and they demonstrated how adopting the so-called carbohydrate-less meal patterns, meaning by eating carbohydrates at the end of the meal, was able to reduce postprandial glucose levels to a similar extent compared with what we can achieve using nutrient preloads. So where are we now? So we have recently reviewed the available literature, and there appear to be quite a large and still growing body of evidence supporting the opportunity of tailoring the nutrient sequence of food consumption to manage postprandial hyperglycemia. And this is particularly true in people with type 2 diabetes, where this nutritional intervention was able to reduce postprandial glucose peak by 40–50%, and also to reduce the overall postprandial glucose excursion by 30–70%, again depending on the experimental conditions. However, there are several limitations and knowledge voids that must be acknowledged, and I'd like just to underscore that there is only very limited available in the long term. And so I think that the biggest challenge for the future would be actually assess whether nutrient sequencing is feasible, sustainable, and also cost-effective in the real world. Actually, we were among the very few groups who have studied in a pilot trial the long-term effect of the nutrient sequencing. This was a study involving 17 individuals with well-controlled type 2 diabetes, and we tested the effect of an 8-week balanced mild hypocaloric diet, focusing on nutrient sequence during the two main meals of the day, compared with the standard isocaloric diet. Well, well, actually, I just want to point out that we were probably in the right place in the world in testing this hypothesis. And in fact, the nutrient sequencing applies very well to a traditional Italian full meal, which typically consists in two main dishes, one primo, rich in carbohydrates, and one secondo, rich in protein, fat, and vegetables. So basically, we just have to ask people to invert their habitual order of food consumption, and only when this was not applicable, we asked them to consume a small nutrient preload, consisting of either a small portion of Parmesan cheese, vegetable, or nuts. So over the 8 week of the diet, we observed no differences in body weight, no differences in body weight changes, and a very good adherence to both the diets, and we were really concerned about this point, and not safety issues. But with regard to glucose control, actually we observed a much greater reduction in the postprandial glucose excursions, and also a reduction in the coefficient of glucose variations in people randomized to the carb-last diet, and they also showed a trend towards greater decline in the A1C. So based on this pilot trial, we are now ready to commit to a full-powered, longer and larger study, this time involving both people with type 2 diabetes and also with prediabetes. Now, during the last part of my presentation, I will briefly come back to the concept of nutrient timing, just to stress that point that it may refer not only to the timing of carbohydrate consumption within a meal, but also to the timing of carbohydrate consumption within the day, as this latter has been recently proposed as another potential determinant of postprandial glycemia. In fact, there appear to be, at least in people without diabetes, a quite relevant diurnal fluctuation in glucose tolerance, as the same high carbohydrate meal has been found to produce much higher postprandial glucose levels when consumed at dinner than when consumed at breakfast in people with normal glucose tolerance or with prediabetes. However, we still don't know whether this also applies to people with type 2 diabetes or whether we can use this information to actually prevent and manage their postprandial glycemia. Therefore, now we are carrying out a randomized parallel open-label control clinical trial with a target enrollment of 50 individuals with type 2 diabetes, this time testing the effect of a 12-week balanced mild hypocaloric diet, focusing on the distribution of carbohydrate within the day. We like to refer to it as the no-cal diet, which stands for no carbs after lunch, and we compare it with a standard isocaloric diet. For the moment, we have enrolled 12 subjects who completed the study interventions, and I can show you that we found a very good adherence to dietary recommendations in the people randomized to the no-cal diet, as demonstrated by the disappearance of the third glucose peak in the evening, as shown by their continuous glucose monitoring. I also have some interim analysis showing beneficial effects for weight management and for glucose control, but again, these are just interim analysis and preliminary data, so I truly hope to show you my final results perhaps next year in Vienna. So in summary, I think I convinced you that the timing of carbohydrate consumption is definitively a key determinant of postprandial glycemia. The so-called nutrient sequencing, which again is eating protein and fat-rich foods or vegetables before carbohydrates, can lower postprandial glucose excursion, at least in acute experimental conditions. This effect increases across the spectrum of glucose intolerance and is comparable and possibly additive to that of current pharmacotherapy. The mechanisms I showed you include delayed glucose absorption, enhanced glucose-stimulated insulin's feasibility and cost-effectiveness for glucose control and weight management. Diabetes is becoming one of the most prevalent. I think that in this context and based on the research studies I just showed you, I think these results really lay the groundwork for adding nutrient sequencing to our armamentarium against diabetes. So I'd like to use the last minutes of my presentation to acknowledge all the people who have been journeying with me during these years and who contributed so much to my education as a clinician and as a researcher. In particular, Professor Andrea Natali for his long-standing mentorship. And of course, none of this study would have been possible without the generous contribution of our study volunteers and without the financial support of our funding agencies. And I'd like to acknowledge the contribution of the Italian Society of Diabetology and also of the EFSD through the Future Leader Mentorship Program. And my deepest gratitude belongs to the EFSD for having always challenged me so much like this evening, but also, and most importantly, for providing me with the best training, networking, and let's say entertaining opportunities. And finally, my gratitude also belongs to my growing family and my loving soulmate for the unconditional support. And finally, thank you all for being such a wonderful audience. Thank you so much.
Thank you, Domenico. I think everybody will think about how they eat tonight. So in a few hours, be good sports and eat carb last. So you will also get a diploma.
Thank you. Thank you. Thank you so much.
And with this, I would like to thank you all for being good sports staying here. There is still hope for European research. We have youngsters coming here. Please be nice to them this week. They might be your bosses in a few years. Good luck.
Domenico, tu conosci Cecilia? So if I do something here to the stage tomorrow,
telephone, maybe not.
I mean not myself, but I have like everything for tomorrow.
We'll put it somewhere there and then...
All four come up here now.
Where put it?
Future diabetes. I had your boss, Kasha Foundation, stay in spirit of June. She came to the... Didn't? She was up for it. Okay. Good. Good work. Then smile. Good work. I will take an extra photograph with you because then, do you see my... So we stage it like they do when they do films. Okay, good. She was in the I was in Barcelona, yeah. I was because there's another
No.
it's always fun.
As the official journal of the European Association for the Study of Diabetes, we don't just deal with Europe. Diabetologia takes submissions and has authors and readers that span the globe. From basic research through translational and clinical science, we bring you the science first as it moves from benchwork, early research on cells and animals, right through to humans and whole populations. Wherever the breakthroughs are coming from, we cover the whole story. our worldwide team of authors, editors, and referees means that Diabetologia provides a global view of everything to do with the study of diabetes. We pride ourselves on high editorial and ethical reporting standards and are looking for original, groundbreaking studies that will make a difference. We work hard to provide rapid review and triage papers quickly so that unsuccessful authors are able to take them elsewhere faster. We don't believe that money or a complicated submission process should be a barrier to the sharing of scientific knowledge. So we have no submission charges or page charges, and we don't make fixed demands on submission format and style. If the science is strong enough for us to publish, we will work with you, one-to-one, to help you prepare the paper for publication. We believe in the power of human-to-human interaction, so our editorial staff are always on hand to provide personal support. With our professional copy editors and proofreaders, we will take you from acceptance to online publication within a month. Aside from inclusion in the print copy, being published in Diabetologia means promotion of your work through social media, the option to publish with open access, and if appropriate, press releases issued to the mainstream media. So, while we might have a bit of an old-fashioned name, it's a name that carries weight, a name that represents a safe pair of hands carrying your discoveries into the world, and a name that for over 50 years has carried the cutting edge of diabetes research and knowledge accurately and responsibly into the future. As the official journal of the European Association for the Study of Diabetes, we don't just deal with Europe. Diabetologia takes submissions and has authors and readers that span the globe. From basic research through translational and clinical science, we bring you the science first as it moves from benchwork, early research on cells and animals, right through to humans and whole populations. Wherever the breakthroughs are coming from, we cover the whole story. Our worldwide team of authors, editors, and referees means that Diabetologia provides a global view of everything to do with the study of diabetes. We pride ourselves on high editorial and ethical reporting standards, and are looking for original, groundbreaking studies that will make a difference. We work hard to provide rapid review and triage papers quickly so that unsuccessful authors are able to take them elsewhere faster. We don't believe that money or a complicated submission process should be a barrier to the sharing of scientific knowledge. So we have no submission charges or page charges, and we don't make fixed demands on submission format and style. If the science is strong enough for us to publish, we will work with you, one-to-one, to help you prepare the paper for publication. We believe in the power of human-to-human interaction, so our editorial staff are always on hand to provide personal support. With our professional copy editors and proofreaders, we will take you from acceptance to online publication within a month. Aside from inclusion in the print